Welcome to Ask Caleffi, the podcast that dives into real-life problems that plumbing and HVAC technicians face in the field. We're your hosts from the Caleffi Tech Support Team. I'm Greg Tubbs.
And I'm Dan Furcus. Welcome. We look forward to sharing some stories from our tech calls and using our background and expertise to make your days a little easier.
Hey there, welcome back. We're here for episode 13. We're talking water quality, in particular water quality and hydronic systems. We have a guest today.
We do. Yeah, welcome back, everybody. So today we have actually our general manager, Mark Olson, joining us.
Hi there, guys.
Hey, Mark. Welcome.
Thank you.
So, an all too common issue I think we run into in hydronic systems is a problem with the lifeblood, the water quality.
Sure.
Yeah.
What can we do to solve that problem?
Well, we've got a lot of products that'll help clean it up, but the first thing you need to know is what's actually happening inside and why it's happening.
Yeah, I mean, being that you've probably been here the longest of all of us, you've heard plenty of horror stories, haven't you?
Yeah, just a few, and seen a couple, actually.
Yeah. Get a phone call about a product that doesn't seem to be performing, and it ends up being a water quality problem.
Mm-hmm. Right.
So what is one of the biggest things that you think should be done to prevent a problem with a product that's water quality related?
Well, I think you have to step back and think about water quality. I mean, there's two aspects of water quality. There's mechanical. That's the stuff that's heavy. It's it's in the bottom of your system. Maybe it's the effect of corrosion, and oftentimes it's an issue when you are doing a retrofit and you're looking to replace a component and you have compromised equipment. That's the easy stuff to solve because you can flush that out with a high velocity flush and get all the debris out. Because if you don't, or if you miss a big leg when you're purging, some of that stuff that's been sitting around can end up coming back and roosting somewhere it shouldn't be in your system. Could be a pump or whatever.
Yeah, but I think that's kind of a big part when you're doing a retrofit is getting in there and trying to clean that system out before you put that new equipment in, and then looking at what you're using or what the quality of the water is you're putting back into the system.
Right, and you might not, as the contractor, have the history on that system. If you're going in, I'm not sure how old it is, and we were in a job down in Kenosha, Wisconsin, a couple of years ago, and it's interesting. And they had a water quality problem. It was a new contractor brought onto the job because the first guy kind of disappeared. And his turned out to be more of a mechanical problem. He had a lot of corrosion in the system from years of oxygen getting into the system. And so basically between flushing and using a magnetic separator, he was able to clean that up pretty good.
Sure. Do you have to go in there and do anything for air separation to try to get that oxygen out?
They actually had pretty good air separation on somewhere in the system, and it was a big job. It was a big campus down there, and he didn't even have the blueprint on it in terms of where it went.
Okay.
So he had to just power flush it, and then he still had debris in there. So rather than let that debris come around and end up roosting in your condensing boiler and creating a problem, then they had the boilers going out on high temperature or low flow. They were able to correct that. But that's the mechanical side. That's stuff that Y strainers and dirt separators can take care of. I think the tricky part, to answer your question, Greg, is water quality is largely chemical. And when you get into chemistry, now it's a whole new ballgame because as much as water chemistry is fairly straightforward and water is pretty predictable in its behavior, when you start mixing it with things, then it starts to get a little tricky.
It does get tricky, and that's the easiest part to overlook is the chemistry, because you can pour system water into a clear glass, and look at it and go, yep, it looks clear, it looks clean, it's all good to go. Or you're going to see the mechanical stuff. You're going to see the rust and the corrosion and the debris that's existing in the system from years of being in service, and a lot of oxygen being
and a lot of different types of metal components
that too
joined together. Then introduce fluxes and solders and other components and chemicals. All of that reacts with each other.
Thread tape and pipe dope. I mean, there's a lot of different other chemicals. Yeah.
Well, I think the first thing, you just, whether it's a retrofit or a new system, even a new system should be fleshed out real good. Manufacturers might have some kind of residue, some type of film left over inside their tubing or whatever. from the manufacturing process. That could react with perhaps chemicals that you might end up putting in the system. So it's good just to flesh that all out. That's where a detergent comes into play, a nice cleaner, high velocity flush, whether it's new or old. Yeah, now you're dealing with a new set of cards, right?
Right.
But then what kind of water do you put in?
Great question. And the answer is, I'm guilty of it, and you've done it too.
I'm guilty of it. Absolutely.
We're given the job. Our marching orders are, here it is. You go put this boiler in. They need to have heat by the end of the day. So, okay, this is what we're doing. And it's a big job in itself sometimes to reconnect and repipe from an old style boiler, old cast iron, to now a condensing boiler. And we go put that in and run it. And
you're filling it with what's on site.
You have no clue.
Exactly. Yeah. We did a survey. I'm not sure if you remember that, Greg, in a Coffee with Caleffi some years back. We said basically what kind of water they're using or what kind of treatment. And about a third of the respondents, and this is a couple hundred guys, our base, hydronic contractors and designers, about a third said site water. They just use whatever's on site. It could be well water. It could be city water that the house is using or the building.
Or softened water or hard water.
Well, then the other third softens it or demineralizes it. And then the other third will take the site water and put some chemicals in it.
Sure.
Right.
But you don't, the issue, I think, is by site water. A lot of site water is pretty good. If it's relatively low in minerals that have been dissolved. For instance, some municipalities will pull their water from surface water, a lake or a river.
Sure.
And that tends to be much less hardness than, say, groundwater.
Right.
Okay. But when you pull in groundwater, now especially in a limestone area, you're going to have quite a bit of scale that can come out of solution. And where does it want to come out of solution? In the hottest part of your system.
Absolutely.
Which is always your heat exchanger.
That's where you'll see that scale build up. You'll see inefficiencies.
I was in Salt Lake City some years ago and with our rep out there, and it was interesting. I forget the name of the contract, real sharp guy, but they just had a run on these boilers that were just failing. And he had all of these water tube boilers, heat exchangers in his shop. He had to cut several of them open. And you look inside, and it was very obvious. It was simply hard water that was coming out of solution.
Absolutely.
Yep.
So that water was put in. It wasn't treated by any means. It wasn't softened, but with a water softener, and obviously didn't have any treatment.
Right.
Yeah. That scale is going to, or the lime and mineral deposit is going to precipitate out of the water as you heat it up.
Yeah. Right.
And it's going to collect right in that heat exchanger.
And you can have the best water air separator in the world. It doesn't make any difference. That magnesium and calcium is going to come out of solution, and it's a good scrubber. It's a good softener. In fact, a heating system, if you have hard water, because over time, what's going to happen? That heat exchanger is going to find all the hardness and bring it out of solution.
Certainly will.
Yeah, just so I think that just kind of knowing what kind of water quality you have when you fill a system, even if it's site water, a quick test. What kind of conductivity are you getting, so you know how many total dissolved solids are in the water.
Right.
And that might be a lot of places in the United States, the total dissolved solids is largely just hardness. Mm-hmm. It isn't these other chemicals, these chlorides and perhaps iron and some other things. It's largely hardness. And you can treat that simply by softening it, and then you're pretty good to go. Although by softening water, then you start entering into the other part of problems, and that's corrosion.
Corrosion, yeah, absolutely.
Because you're increasing that conductivity when you soften water, right? Yeah. So, and you also can raise the pH as well, which isn't too big of an issue, except when you get into aluminum heat exchangers. They don't like high pH.
Yeah, aluminum does not like high pH.
No, we've replaced a few of those in our day too.
Absolutely.
Yeah, I suppose.
Only after we've gone through all that.
Right.
And that's the tough part about it too, is like we've had to go back, well, hey, you were the guy that installed this thing, and now why is it giving me problems?
Right.
So because we didn't know any better, this was back in the late 90s, early 2000s when you
were seeing more and more aluminum heat exchangers.
More aluminum, and you were seeing the tight passage stainless ones with the Giannone type heat exchanger in them, and they got hot, and they did what they did.
Right.
They limed up, and then you're getting called out there for a low flow problem.
Yeah, you saw a lot of them piped incorrectly too. You didn't have proper flow rates through the boiler, creates hot spots, which separates that Lyman scale.
Yep, right. That's exactly it.
Right.
So getting to the bottom of it is really, in an ideal world, in a perfect world scenario, before you even take on the job, maybe you draw some water off and have it tested or test it, do a test.
Sure.
Ideally, that would be the best case scenario. Obviously, it doesn't happen very often, and this is what you end up with, is a scaled-up boiler.
Right, or a good boiler inhibitor going in as well to help with treatment and protection of the internal components.
Right. That's also something that needs to be done.
So, yeah, you look at the water quality. Remember that water quality sample that I put together, where I had a jar with all different types of components, from steel to black iron to copper. I had a piece of flux. I had a piece of solder in there, flux, Teflon tape. I had all the different metal components together, brass and bronze as well, and filled it with just tap water, and then filled another jar with the same components with tap water and inhibitor, and another jar with just demineralized water, and a fourth jar with demineralized water and inhibitor. And it was amazing. Within a week, the jar with just tap water, and this is city water, it's, treated locally, that was already starting to get hazy and cloudy. The demineralized water had a little bit of cloud to it, but when you added the inhibitor, it kept it a lot cleaner. And ultimately, in the end, after about 4 months, the demineralized water with the inhibitor is, even still today, I looked at it today, it's spotless clean. Looks like I just filled it.
Right. Now, demineralized water is probably more expensive than other forms of treatment, I'd say. You go down to the grocery store and you get distilled water, was it 99 cents a gallon or something like that?
Right.
Somewhere in that range here. So, I mean, it's not too terribly expensive. But, I mean, the ideal water to prevent any type of problems is demineralized water and one heck of a nice air separator. So you keep that oxygen,
absolutely,
oxygen down. If you do that and prevent any type of water coming in from a makeup standpoint, have a good solid system designed so you're not leaking and getting makeup water back in. What does makeup water have? It has dissolved oxygen in it.
Right.
So that's what you're trying to keep out. So demineralized water with a good air separator placed properly in your system, you're going to be good to go. You don't even need chemicals. In fact, in Germany, they really preach water quality. There's a society of German engineers that created a standard for water quality. We don't have that here in the United States because our hydronic market's nowhere near the size of Germany. I think they sell like 900 million boilers or something a year.
Everything's heated with water there.
Right. Everything's heated with water, so they take it to a whole new standard. But they really frown on chemicals, and they emphasize get the conductivity of the water, the electrical conductivity, which is driven by how many minerals have been dissolved in it, whether it's calcium or magnesium or iron. Anything that gets dissolved in water will raise its conductivity. And as strange as it seems, if you get rid of all that conductivity, and we think of water as something you can get shocked if you got current voltage on you, it's actually a resistor. And if you can get rid of all the dissolved minerals, then you have basically prevented. It's like taking a car and disconnecting the wire from the starter to the battery. Okay, the battery's there, which is the dissolved oxygen, perhaps. Okay, that's really the driver of corrosion. But by cutting the battery cable, it's the same thing as basically eliminating that conductivity inside the water. Yeah.
Sure.
Yeah. And if you do that, you could keep the system like that forever, as long as nothing else gets into it.
Right.
And it shouldn't if it was well designed.
Yeah, you're right. If it's a well-designed system and you're not adding makeup water and you have all the oxygen out of it, you're not going to have issues.
Yeah. I think that probably the biggest, maybe not the biggest, but a very common problem with water quality is when you are using antifreeze. What's the typical type of antifreeze we use around here?
Propylene glycol.
Propylene glycol. Yep. Right, propylene glycol. And propylene glycol, it's a scavenger of oxygen. It likes to, if you have any dissolved oxygen in your system, it's going to absorb that, scavenge that. And what that does over time is the pH in the system starts to drop.
Right.
And it becomes acidic. Now its ability to corrode components especially ferrous components, iron, your piping, it gets quite aggressive.
Yeah, it just accelerates.
Yeah, and we've seen some hydro separators come back here that obviously were in a glycol system that got real acidic because it ate a hole right where where the weak link was in the hydro separator, which is typically in a weld joint or something like that.
Right. Yeah, that's where especially a glycol system, you need to be doing maintenance and managing that glycol level and the quality of that system so that it doesn't become aggressive.
Hey, you probably have experience going back and seeing these acidic glycol systems.
Yeah, we've seen that. It's pretty amazing how that changes, and it does. You're right. It gets really aggressive. I've seen it eat out buffer tanks and hydro separators.
Again, if you could drive off the oxygen with a very well placed, a well performing air separator, a coalescing air separator placed after the boiler where it's the hottest, and drive all that dissolved oxygen, not let any more oxygen in. I mean, that glycol can be maintained for quite some time because now it's just doing its job of antifreeze and it's not degrading.
Right. Now it's providing freeze protection instead of...
That's what it's supposed to do, right?
Right. Yeah, absolutely.
But you got to keep your eye on it because, especially if it's not your system design and it's got something that's got compromised over the years.
Yeah.
So really what it boils down to is system maintenance. System maintenance on the piping, the boiler itself, the fluid quality.
Yeah.
It all works hand in hand.
Right.
So if you fall behind on system maintenance, it's always up to the homeowner or the business owner, the customer, to be adamant about it.
Right. Try to get them on a maintenance contract so you're coming in on a routine basis to provide that maintenance.
Yeah, let them know they have there's chemicals if you're going to use chemicals, let them know and that it has to be maintained. Even glycol aside, even your conditioners.
Well, and especially any high efficient boiler. I mean, maintenance is so important, more important than anything with a high efficient condensing boiler.
Sure.
So getting in there once a year and getting them on a regular routine and educating the customer that you know what, it's in the end it's cheaper to do your annual maintenance and stay on top of it than it is to wait till there's a catastrophic failure.
Yeah. Right. And a lot of that's recommended right by the boiler manufacturer too.
Yeah.
Here's your water test. It has to meet these certifications. These readings have to be read every year. So, I mean, you and I are familiar with one particular brand of boiler that if you didn't go and do the test, it was a matter of dropping 2 little caplets in a vial and shaking the water, and it would turn a certain color.
Right.
And that would tell you, okay, we need to do this, or nope, your fluid is okay.
Right.
Yeah.
And that was part of their maintenance kit.
It was part of their maintenance kit.
A survey we did as well about water quality is some years back, and it was another couple hundred respondents, Coffee with Caleffi webinar survey. And the question was, what causes hydronic system failures? The question was, and it was a multiple choice of six answers or something like that. 66% of the respondents responded that water quality is whether directly or indirectly affected a failure of a hydronic system design. 66.
Wow.
2/3.
Yeah.
Not a component that fatigued, not something that broke, not something that wore out, which was what we relate to anything else that's mechanical.
Right.
It was a water quality. And water quality can be addressable.
Yeah.
It needs to be maintained.
Yeah, I believe that. I absolutely believe that's the fact.
Yeah.
We believe it because we've lived it the hard way.
I know.
The hard way of breaking the bad news that, your fluid wasn't up to par and it caused the failure of the boiler, or it caused the failure of the pump.
Yeah,
we had a lot of iron in there and it was a variable speed pump.
Mm-hmm. Yeah.
That was part of it.
Yeah. Right. So it's a big issue. It's complex because it gets into chemistry, but some practices that get put in place can really make it a lot easier, and that's making sure you clean the heck out of a boiler system, a hydronic system. If it's a retrofit, just purge it. If you got compromised things, replace it. Make sure you got some good working materials going back and doing your retrofit. And even in a new one, just get any materials out of there. And you mentioned too, Dan and Greg, just simple things as copper shavings, pipe tape. I mean, we've seen all that stuff before. We see now no magnetic separator is going to be able to get that stuff out. And if it survived a good purge, now you're reliant upon some separator to to get rid of that stuff.
Right.
And that's where a dirt separator comes into play, because it doesn't work off of magnetism. It's just getting rid of that stuff that doesn't get attracted by a magnet.
Right.
That could create havoc on something. It could cut.
Absolutely.
Yeah. I mean, think of copper shavings. Those are sharp.
Yeah. Oh, yeah, they are. They'll get lodged anywhere in heat exchangers, pumps.
Even just small shavings.
Right.
It's the small stuff that really becomes the problem. Even corrosion, it starts off as microscopic. When oxygen reacts with, say, your pump volute or your expansion tank, anywhere where there's a ferrous material,
sure.
It's not like all of a sudden it's like a rusty barrel kind of look. It's like powder that creates the corrosion effects, and it sloughs off and it starts flowing around in your system like the consistency of baking powder. All right.
Right.
And it floats around and floats around. If it's not captured, it floats, it settles. The system turns off, it settles, and the system turns back on. It floats around. Well, over time, if it's not treated, it kind of starts to cake. Mm-hmm. Almost like if you take a baking powder and you put it on your counter, and on a humid day, and you come back an hour later and you try to blow it off, it's already caked there. So now nothing's going to treat that. You can't put a big magnetic field in there and try to retrofit clean that.
Right.
And there's just nothing now you can do, but other than just the old-fashioned way, purge it out.
Mm-hmm. Power flush.
And that's why even with a retrofit application, I know when I was going in on calls or presenting projects for retrofits, we always went in and did a clean and flush on the existing system before we put the new equipment in, because one deciding factor to replace the equipment, might be that it's old equipment. Another one might be for efficiency. So, you look at an old system, especially with radiators or European style radiators, any of those grooves or surfaces that become caked with material become less efficient for heat transfer.
Sure.
So if you could go in and take a thermal image camera and take a picture of a radiator before and then clean it, I bet you'd see afterwards it's quite a bit more efficient in heat transfer.
Oh, yeah. If you think of a micron, one micron, I think there's no millimeter, not a micron. Can't see a micron. What am I saying? I'm sorry.
Darn good eyes.
Right.
If you just take your heat exchanger, whether it's a instantaneous hot water heater or a boiler or whatever, and you coated it with 1 millimeter of calcium scale, you've just penalized the heat efficiency for that appliance by 10%. Right. So if you got a 1,000,000 BTU boiler, now you're really talking a 900,000 BTU, and that's just 1 millimeter. 1 millimeter. That's like a pinhead.
Right. Now you build up over time. You really diminish the efficiency and capacity of that system.
That's about the thickness of Greg's fishing line, don't you think, there, Dan? About 1 millimeter. Wow.
I don't know. He fishes for some pretty big fish. I'm kidding.
Big stories anyway, right?
Yeah, right.
So 1 millimeter. I mean, like you said, Dan, just in those heat exchangers, even if it's not even scale, if it's just magnetite that is settled into the bottom of a panel rad or something like that, you're going to penalize its capability to deliver heat back into the room.
Right.
So that just ends up going back around, and you become less efficient in your system.
Yeah.
And I think because of the high cost of not having efficient equipment is why the Europeans really put special. I mean, their cost of fuel is much higher than ours, right?
Sure.
So we don't have really that outlook of really looking at every nook and cranny for eking out efficiency. But they do, and that's why they have water quality standards, and the contractor's liable. He's got to make sure that when he fills a system, in fact, most hydronic systems in Germany, for example, I shouldn't say most, I can't say that factually, but a lot of them, they fill the system up, pressurize them, and then there's no makeup water. There's no autofill that goes on it.
Okay.
If it's losing pressure, okay, maybe you come back out and you top it up, right, to get rid of the last bit of air and then after that point, it's sitting there at 15 psi pressure. As long as if it's sitting there, there's no reason why it should stay there forever. I mean, it's a hydronic sealed system.
It's a closed system.
It's a closed system.
It should stay there.
And if it goes down to 5 psi, that means something, is wrong. So they have to come back out and service it. So there's a much more attention to detail over there. And so, will we get to that point here in the United States with hydronics as far as attention? We might. We don't have a water quality standard, but maybe someday all of us in the industry might gather together. We've talked about it before, but we haven't done it yet. But
yeah, you may see it in time.
It sure increases the level of understanding too when you have a standard like that. People start teaching on it.
Yeah, it does. Well, and I think as a contractor, when you can start to put into place good practices for managing water quality in hydronic systems, you just take yourself to that next step.
Yep.
I mean, because I think that maybe is one thing here that gets taken a little bit for granted. So when you're that contractor that makes that your focus and makes it and puts steps in place to ensure that you're designing, installing, and commissioning that system properly, I think that takes you to the next step.
Well, water quality it's not a real exciting It's not. I mean, when you think about it, it's not very exciting in terms of because you can't get your hands on it.
Yeah,
it's not like
you got to try and wrap your mind around it. And if you're not a chemist and you have no aspirations of being a chemist, it's pretty fill it up, run it, let's go
right
on to the next one.
I mean, ironically, I hated chemistry. I mean, I got into college without having taken chemistry over at Michigan. I'm an engineer, and my first semester, and it's so ironic that now I like water quality and the chemistry side of it. I had a chemistry lab with a prerequisite that you had to have a year of chemistry. So I'm doing this lab, laboratory experiments, and at the same time, I'm trying to read a book that I should have had the lesson on, the prior year. And that put such a bad taste in my mouth about chemistry that it was like from then on, I just didn't want anything to do with it. That's right. I wanted to stay mechanical. But then in this industry, because it became such a big issue, and we saw the effects of a lot of our fellow manufacturers having problems with water quality, especially as they migrated on the hydronic side from cast iron boilers over to the less forgiving condensing boilers, and everyone pointing their fingers at each other as to what's causing all this problem, all these failures. Then I think my interest certainly went up. Certainly Caleffi, so we teach a lot about water quality.
Right.
Yeah. I have a lot of water quality products.
Right. Well, we have to understand that because that affects how our products perform. So it's really important to us that they're getting put in with good water quality so that they last and perform well. Because when they come back and fail because of water quality, and that's traditionally why something is failing, it doesn't make the product look good.
Right. Oh, exactly. Right. Exactly. So there's a built-in interest to really try to understand water quality, and help educate the contractors out there. And it really can be boiled down to some simple practices to really minimize it. But, can't just throw blindly water into a system and hope that it's not going to be a problem, because even if it's city water coming, like here with Milwaukee, I think our water comes largely from Lake Michigan or something, and
it does.
It might have 7 grains of water. I mean, you pop that into a system thinking that you got great water. Well, guess what? That water is going to ultimately, that hardness is going to come out.
It's going to come out. Absolutely.
Where it's hottest again, right on that heat exchanger.
Right.
And if you don't have a failure, at a minimum, you have an underperforming product.
Right. Yeah, absolutely. But then to simplify it, for a lot of the contractors that are listening, they're going to be out talking to the end consumer.
Yeah.
So from an end consumer standpoint, I always presented it when I was in the field. It's like, we're going to take steps to manage the water quality in your system so that, you're going to have a good performing system. You're paying a premium for a hydronic system. And I think, all the guys know that. So when you deliver that product, at the end, it's going to be well performing. It's going to be long lasting, and taking the steps up front and ensuring the customer you're going to do that is what gives them peace of mind to pick you as their contractor.
Yeah.
It's easier to charge them and have them pay for it up front than it is to come back and find out that you did something wrong and have to charge them for it. They're not going to want to pay for that.
No, it's hard to get them to understand that.
Right.
You need to do your job right up front. Yeah. So that's a little bit on water quality.
Yeah. I think we covered it and then some.
Thank you, Mark, for stopping in and
this
some
was
time
fun.
with us.
I'm so happy that I finally got invited to your, what is it, your lucky 13?
Lucky 13.
But
what?
You are guest number 1.
I am.
So you should.
I feel a
that.
bit better about that now. Yeah, thank you. Yeah. No, this is fun. Call me back anytime on this. This is a blast.
Great.
All right. Well, thanks everybody. We'll see you next week.
Sounds good. Thanks for tuning in.
Thank you.
Thank you for tuning in. If you ever need help,
Please feel free to contact our tech support team anytime at techsupport.us@caleffi.com.
or call us during our business hours at 7:30 a.m. to 4:30 p.m. Central Time at 414-238-2360.